This is the short demonstration showing the current status of my project MIDIfy. So what is it about? I wanted to create a MIDI system for Fender Rhodes and other vintage keyboards. While I'm aware that other systems already exist, I wanted a solution specifically tailored to this type of instrument. Existing systems like P&O Scan from QRS Music work well, but in my opinion there is room for improvement. Now on to the MIDIfy project. My goal was to build a high-resolution MIDI system, and now I have it up and running. It works using Hall sensors. Each sensor board contains 16 independent sensors, and to make the system work, a small magnet needs to be mounted to each key. The magnet measures only 3 by 2 millimeters and weighs less than a gram, so it does not affect the key action. The system is designed to be as simple as possible from installation to setup. Here you can see the mounting of the sensor board. It still needs to be made more sturdy, but for prototyping it's just fine. The springs allow for precise regulation and setup. When installing the system into an instrument, it's important to keep an eye on the debug monitor, as it shows the raw values of each sensor. The goal is to achieve a good working range without running into saturation. As mentioned, the system operates at very high resolution. We are talking about 16-bit ADC resolution, which theoretically equals 65,535 steps. We cannot use the full range due to the sensor's minimum output, but that's not necessary at all. To make this more practical, even if we only use 20,000 steps and the key treble is 10 mm, that results into 2,000 steps per millimeter, or 2 steps per micrometer. Resolution isn't everything, though speed is just as important, and I'm proud to say that this system runs at 8 kHz per key for all 88 keys. That means each key is scanned every 125 microseconds. This is especially important for fast keystrokes. We don't want to miss a fast attack and generate an incorrect velocity value, right? If we take a very fast keystroke of 2 milliseconds, that results in roughly 16 measurement points, more than enough to calculate velocity accurately. At the moment, velocity is calculated based on the time between 2 points, but in a later firmware version, it makes sense to calculate the actual physical velocity by tracking the key movement over time. Because the system is extremely sensitive, it should even be possible to achieve usable aftertouch on acoustic pianos. Now, let's take a look at the firmware I've built so far. First, there's the preference panel, which is quite important. Here we set the total number of keys, the MIDI start node, and we can access the debug monitor, which outputs the raw values of each sensor. Next is the calibration tab. To calibrate the keys, I simply start the wizard. Then I press each key down firmly without engaging aftertouch. Once the total number of keys has been reached, calibration is completed. That's it. Touch Select shows the last pressed key and allows me to fine adjust the sensor values if desired. Next is the Threshold tab. Here we define the thresholds, where velocity measurement starts and ends, when a note off is sent, and where the retrigger threshold is set. Additionally, I can adjust the start and end points for aftertouch. Then we have the Velocity tab. This should look familiar if you have worked with MIDI keyboards before. Here we can set the global gain, fine adjust the black keys, and change the velocity curve shape. Next is CC. This is currently a placeholder and will be used later for sustain pedal calibration. Then we have presets. This part was fun. It allows us to create split zones with octave shifts and route each zone to a different MIDI channel. We can also filter whether a zone sends sustain, aftertouch, and more. And as you can see here, this system supports polyphonic aftertouch as well. I've integrated 4 presets. Each one listens to MIDI program change messages, so presets can also be switched from an external device. So that's it for now. Next step is finalizing the hardware, for example, the sustain pedal sensor. I've already tested the system with 73 keys and it performed very, very well. Let me know what you think. I'm happy to hear your feedback. Bye-bye.